it all comes down to how you feed the data in, and also what the quality of the data is when you feed it into the model. Because the machine learning algorithms are gonna learn what you feed it and what you tell it to learn. Like you said, that model, you had to pull something out in order to find what the true, cause of that break or whatnot. So eliminating things that, from a human perspective, aren't the cause, and things that are cross-correlated so that it doesn't overly influence the outcome, right? Because you have two things that are running together, they're just maybe a similar signal, right?
Correct.
And then it overinflates like what happens. So
Yep.
I think that's a big part of it, and I think that's true. When you set it up, you have to have those things in mind, as well as you're working on it. It's an iterative process, right? Let's build a model, let's see how it works, check our percentage and how accurate it was, get people to look at it, get subject matter experts to really get in there and look through the results, change it up, make it better, and it just is an iterative process. And I think a lot of companies tend to think, okay, we're just going to do a quick machine learning project, set it, forget it, and that's just not the case. It's definitely a long-term building process, I think.
Yeah, probably the first machine learning project we did, you hit on data quality and how the data comes at you. We learned that very quickly, because what we did was we took a very wide and very shallow data approach. We took maybe a couple thousand variables in like 1 hour, interpolated values. And the reality is we didn't really understand the signals and what was coming at us in the process well enough. Realistically, what we ended up finding out was the disturbance happened within about a 5 to 10 minute window, right? We could see it with 5-minute data. There's no way we would have found it with 1 minute data, because it would have been filtered out unless we hit it exactly at the right point. The other thing that we found is sometimes the raw data doesn't tell you the whole story too. Sometimes it's a 1 minute average, or a 1 minute average compared to an hourly average, or something along those lines. And I remember this company was trying to help, and the idea was good, and I could see where in other places, other types of data sets it would have worked, was they were trying to do automatic feature engineering. And I remember, and feature engineering, all that really is a data science term where you're trying to maybe take an hourly average, or do some math or some filtering on the data, where it's basically adding another column essentially. So you're adding a feature to it. And they were trying to do automatic feature engineering, and I told them, I said, well, how do you know if I need a 1 hour average or a 24-hour average? Because they were trying to do 24-hour averages. And that doesn't mean anything. Like, the 24-hour average almost means nothing to us, because it looks like this disturbance happens within a very small window, and then we actually see the result hours later, right, to confirm that this was an event. And that was a very interesting process for me, to really understand that. And I think time series data really presents a big challenge in that, because the raw data isn't always the story. Whereas if you're using a lot of relational data, that is your data set. That is the story, right? Here I might take a flow that's a really noisy signal. It's really the hourly average or the daily or monthly average that tells me the story that I need to know for a machine learning algorithm. And so, that's an important thing that a lot of people just flat miss. We missed it when we first started doing it.
Yeah, and I think part of that too is, when you have the raw data, you may have missing values, you may have things where the sensor went to 0 or errored out or different things like that. And that's something you have to look for when throwing data into a model. You never know, like, you're going to get a bad outcome if you have bad data, right?
Yeah, and fortunately, most of the tools we've looked at do a really good job at the filtering part, right? Several of the tools we've looked at, even the one that was not very successful for us, they did a really good job of helping us find those anomalies and get rid of them, right? And so, that's something that, a lot of the machine learning companies will kind of brag on, but, the reality is they all do it, and they all do it relatively well,
Well, part of that as well is you want to filter out things that maybe the algorithm's not going to say is wrong, but the machine was down, or you're running a different style of process, or something different happened in real life that you couldn't just tell from an algorithm from a software perspective.
Correct.
But it's a human filtering issue. So sometimes the raw data isn't always the best.
Yeah, no doubt.
Yeah.